Hello? Oh, there we go. Hello? Oh.
Hello, can you hear me? Okay.
Need set to the lighting. I guess we could do that.
Hello. If everybody could slowly find a seat, we'll be starting in a few minutes. Blue, blue. So the funny thing is, like, I can only really see the people out here, but I know there's going to be loads of people in the back, which is kind of a shame, but also kind of cool. Do, do, do. Oh, yes. Yes. I thought you said Dawn. I was like, okay, cool. Cool. Can I just say that the screen is like amazing? I mean, I didn't really plan for it, but apparently the thing moves up and down too. I'm just randomly saying stuff, so I have no idea if people are actually listening. Does everybody hear me? Hello! Welcome to Docker London! Right, I might as well just start. Does everybody see a screen? If you can't see the screen in the far back with the amazing view of the London Eye, there's a few more screens and a bit more seating space. But it's more fun if you're all here because I can see your pretty faces. Cool. So I'm just going to kick off. My name is Dominique, for those of you who don't know, but I'm assuming most of you will. I work for a company called Technovo. I am DevOps community advocate there. I am... what are you giggling about? Okay, there's also live stream. Hello, live stream. I am the community leader for the Docker London chapter, and I'm also doing other cool stuff in the community. So I'm just gonna. I've got loads of these, so I'm just gonna swing right through. A few community updates before we kick off with the rest of the event. We are live streaming, so if you go to docker.london/video, you can see all the recordings, all the sessions of the previous events. The next Docker London will be the Christmas edition. It's going to be strange in November, but I like to be early. On the 28th, please mark your diaries. And then we've got a cool few other events happening in the next few weeks, like Kuber Autumn, which is a Kubernetes meetup. We've got Cloud Native. I'm saying September, but obviously that's the October one. We've got microservices the week after, and the next day it's got London DevOps. Cool beans. So next week, for those of you who are not aware, DevOps Days London. This is going to be very exciting because I've been very much busy with this for a whole year. And I'm also doing an Ignite. So this is going to be my first ever conference talk, which I'll be doing with that lady over there. She'll be saying a word in a minute. Cool. So if you have your tickets, I'll see you next week. If you don't, wop wop, because it's sold out. A few other cool things to mention. O'Reilly is one of our community sponsors, and they have offered us a discount for 2 of their conferences. One of them is the Velocity Conference in Berlin. You can get a 20% discount on all the different packages. And the other one is pretty much happening on the same day, but it's the same days, but it's a software architecture conference. I'm not sure if it's in the same venue or not. But if you want the discount code, please take your photos, do your thing. Right. Leave it up for a second. Cool. So, meet some mates. So, I'm obviously talking about meet and mates a lot, but it means a lot to me. Who here is a meetup mate? Could you all give a little whoop whoop? That's very underwhelming, but I know you're here because like I've heard there's like 12 people meeting. So if you want to get involved with that, it's basically a community run on Slack. If you don't have anyone to go to meetups with, basically just like find other people to hang out with. So register over there. You can find us on Twitter. Cool. So more things. We're having a raffle. So JetBrains has been so kind to give us a few 1-year licenses to give out for free. I'm not really good with raffles generally, but came up with one anyway. You can get a free 1-year license, like with all the cool things. I think the Go Land ones in there, basically just a thing. So how to win this? You can tweet a photo with hashtag Docker London and hashtag JetBrains during this event. Make sure you make it a funny caption because the one with the best caption will win. We'll be announcing that tomorrow online. So make sure you get your tweets in. Yeah? Yeah. Woo! Loud. Okay, cool. So this month's event is proudly sponsored by a few interesting companies, and I would like to invite Kat to come downstairs to say a little something about Technovo.
It's the first one of these I've done, so be kind. But Technovo, for those of you that haven't heard of us, we're a digital consultancy. Both of us work there. A few of us also in the room also work there. We like to work with our clients that are currently undergoing change, whether that's transformation, migration, DevOps adoption, anything like that. We like to work a little differently to the traditional consultancy. We foster a culture of zero dependency. We've got some really cool clients at the moment, some really cool projects, from large enterprise down to startups that are currently undergoing their series funding. If you work for a business that's undergoing change and having some trouble with that, we can offer some external advice. And equally, if you're just looking for a next challenge, then we've got some, like I said, some really cool things we're working on. So get in touch, technovo.com. Thanks.
Woo. Awesome. Oracle Cloud, yay. No, Oracle. No, okay. I'm kidding. Oracle's been very kind. They've been sponsoring Docker London for the last 2 years, basically. So they've been very, very cool partner for us, which helps pay for, the meetup live stream stuff. So thank you for that. Influx Data. Is there any from Influx here or anyone from Oracle wanting to say something? Cool beans. Right. Could you ask Josh to come on stage, because they've been very kind to open up this amazing space and get the pizzas and the drinks in for us. So give an applause for Josh.
Thanks, everybody. My name's Josh. So I work here at Condé Nast. Just a few housekeeping things. So toilets are last door on the left, going down that corridor there. If the Condé Nast staff could put their hand up, you'll need a pass to get back through the door. So just see one of those folks or come see me. There's obviously the screens at the back, so please feel free to get comfortable at the back there with the screens. Take a photo with the flowers, read some magazines. Don't take the magazines.
Very important, don't take the magazines.
And I guess I should say that we are hiring. We're hiring platform engineers and SREs. So if you are interested in working on some interesting problems, we provide the sort of base level platform for over 300 million users. So we work on big problems at big scale. So come and speak to me or any one of the other Condé people here. Thanks.
Thank you. Josh has done actually a few talks about what they do. So I'm sure if you Google also speaking at Velocity, so all cool things. Right. So back to the order of business. This is the agenda for today. Obviously, the introduction is happening now. First off, we have Corollis talking about his webhooks project. And then we got Mark talking about your kernel and you, which is absolutely really funny title. And then we have a short break. And then last up, we have Kevin from Instana talking about some microservices and releasing confidence. Right, so let's get the show on the road. If you want to get involved, just go to this URL, docker.london/get involved. We always are looking for sponsors, venues, speakers, etc. So come chat with me. Have a fun evening, everybody. Yay. Cool beans.
Is my mic working? Yeah, okay. So I'm Carlos. I'm a a software developer. Today I'll be talking about Webhook Relay. A little bit about me. Currently I'm mostly working on data science. It's my main client. We are building a machine learning and data science platform where we're using Docker, Kubernetes, and many other technologies. I'm also working on Webhook Relay. It's my side project for the last several years. And while doing Webhook Relay, I also created Keel, which is an operator that automates deployments in Kubernetes. Previously, I worked in Storage.js, where I was developing software-defined storage array for Docker and Kubernetes. And before that, I was working in OpenCredo, where I mostly worked on a service virtualization tool that was simulating APIs for one major airline company. So today, I'll be talking a bit about what kind of problems I'm trying to solve with Webhook Relay. It's objective, some use cases that might be valid for you, tech stack in the backend, which can be quite interesting as it's a one-person company, and just main challenges. So as like an overview, what it does, it creates a unidirectional tunnels that allow traffic to go into like any service deployed in the backend, for example, in your Kubernetes cluster or just regular VM. It can also create like bidirectional tunnels to expose services. And now it can also provide connections through WebSockets. And from there, we can get some more clients connected. For example, Node-RED, if anyone had a chance to use it, it's like a workflow engine. Relay agent is written in Go. Most infrastructure is written in Go. It just makes it way more productive. Well, the problems. First time I had this problem in Barclays when we had to enable some automation in our Jenkins from GitHub and GitLab, and it just wasn't possible. Like networks team were just were not interested at all into providing us with endpoints where we could pass traffic to our internal services, and it was just impossible to do anything. So we kind of had to use polling, which would lead to either us being rate limited or updates waiting for like minutes or even longer before it would actually start new jobs. Then with each new CI system that's introduced in an organization like Jenkins or GitLab or Drone, it's you have to repeat the step one where you ask another team, or you have to do it yourself to provision those public IP addresses, then configure firewalls to let the traffic through. And also there's very little audit logs when, for example, you're receiving webhooks straight in your Jenkins instance or Drone. Well, in Drone case, there are no logs at all, or GitLab. In Jenkins, there are some logs in a system tab there, but it's also quite difficult to debug. And also just needed a side project. I was working for a 9-to-5 job and just wanted some new challenge. So the objective was to create a service that I can use myself, first of all, to help me with, for example, like Stripe development, especially now with the new secure customer authentication law in EU, it's a lot easier to use Stripe checkout, which is very asynchronous, where you actually pay on Stripe's page, and then you're just receiving webhooks from Stripe that someone got a new subscription or someone paid, and you have to process those webhooks. And to actually do that, you always need to somehow receive those webhooks. So how do you do that on your own laptop? You probably have to either deploy it to some kind of staging or development environment, or use one of these tunneling solutions. So customer use cases, as I said, mostly it's webhook forwarding to CI system. I think most of my users are just Jenkins or Drone or GitLab users who find it a lot easier. Then there is a group of developers who are just working with Stripe or Chargebee. Chargebee is like Stripe, but a lot slower, and execute scripts on webhooks. This feature is quite new, which is cool. or just demo anything from your local host, like a static web server that you have, like Hugo or Jekyll. Doesn't really matter. And I think a year ago, I started working quite a bit with home automation solutions, because a lot of people were asking like whether they could have like a bit more integrated add-ons. So it was quite fun, especially, for example, with Node-RED and Home Assistant. Home Assistant can integrate with pretty much any devices you have at home. Well, those devices have to be like smart, but it is quite useful. Like I can turn on and off TV in my room, which is very useful through Google Home. Jenkins builds on pull request. This is sometimes is quite even strange, and especially in 2019, that you have to do something special about Jenkins when you want to do builds on pull requests. Like most of the other CI solutions just do this out of the box. But with Jenkins, you kind of have to get a bit more involved with like specific plugins and just to receive webhooks somehow. So recently, one of the large computer chip manufacturers started working with me, just to enable CI in their organization. Then obviously .science, my main client that I'm working with. So we are using tunnels with Jupyter notebooks. So how it helps us is that any workload that data scientist runs, we run on a separate VM. And some of those workloads can be like long-running jobs like Jupyter. And it really helps to actually start a Jupyter on some remote machine with, for example, NVIDIA GPU on Google Cloud. And you don't have to care about networking. You can just start a tunnel there, and you can now connect it through the browser without messing with firewalls. Also, currently, we started working on deployments. So we are using TensorFlow serving to create those deployments. And Webhook really has an ingress controller that can create tunnels directly to those deployments, also avoiding to configure load balancers. Because usually each load balancer costs like around 20 pounds, at least on Google Cloud. So it can accumulate, especially when your workloads can be just like more like development or staging, where you don't need to have like a high throughput. For production environments, we will be using just standard load balancers from Google Cloud. All tunnels can be created directly through the API. There are no configuration files. You just post, put, and delete HTTP requests, and your configuration is updated on the fly. Home automation, as I mentioned before, I don't know how many of you have tried out like working with IoT and what kind of problems you get, but some of the users just are behind CGNAT, which basically just several levels of NAT. You just can't expose your local web servers to the public internet. Like even in my case, I think I have to pay additional 5 or 10 pounds just to get a public IP, which is okay, but I think without paying that is a lot better. Well, a bit more about integration with Cloudflare. Let's encrypt. I think, yeah, Cloudflare is really nice working from like a client perspective when you want to configure it through the API, especially like DNS configuration. Like I've seen many other DNS providers, and I think like Cloudflare is probably the nicest API. And recently they also introduced like tokens per zones, which really helps, because previously, even now you can have like a global API key, which if you leak, it's like opens the gates to all your domains. Okay, now about a bit tech stack. So from language perspective, backend is written in Go, as I mentioned. Frontend is written in Vue.js. Previously, I worked, even now on the science, we do quite a lot of React. But I found that I'm way more productive with Vue.js because there's just a lot less ceremony if you want to accomplish something. For the protocol between agents and servers, I mostly use gRPC. I remember there were some issues a few years ago with gRPC and load balancers, especially in cloud environments, where they would just cut your connections and nothing would happen. Like the client would still think that it's connected. But recently, like all of those issues were fixed on the gRPC side. There are really nice keep alive and timeouts can be specified during configuration. As a framework, I use Beautify. It's material design. It's really nice. I noticed that it's really good from performance perspective until you get maybe like a few thousand elements. Then it can be a bit slow, but still, like from developer's experience, I can say that it's like top notch. The backend side from database perspective is quite boring. I'm using Postgres. Don't really regret it. Not a fan of Mongo. And Redis for caching and Nast for messaging. So Nast is, I don't know if there are people that are not aware of it, but it's like a Kafka or any other messaging systems. It can be made like HA that won't lose any messages, but by default I use it just for messaging between the nodes, which is really nice. As an infrastructure, I use mostly GCP with GKE. I can't spend much time on ops, so I try to just get a managed service. It's a bit more expensive than just plain VMs, but to be honest, can't tell a difference from the billing invoice. I also use Vultr for like cheap servers for multiple zones. Vultr, I noticed that they have quite nice, not official CLI, which really helps. I don't know why they haven't forked themselves, but like from pricing perspective, it's quite good. Then I have lots of helpers. So for example, Grafana and Prometheus, standard things. I wish I had them a lot earlier. I think I only started using Prometheus after like few months after deployment, when I noticed that all my APIs became quite slower. And then I was like, interesting. So apparently they were a lot slower because I was logging a bit too much in like a blocking way. I also use Cloud Builder. It's if you don't have like too many builds, it might be a perfect solution because it's free. It's very fast compared to like Circle CI or Travis or any other like, God forbid, Docker Cloud. I currently also use Drone that does a bit more than Google Cloud Builder, but just from that perspective that I want to run it on my own servers. I also use Node-RED for a lot of workflows and automations. It's doing health checks, also receiving webhooks from Mailgun and sending everything to my Slack channel. It's a very sad Slack channel where I'm the only person in it. Yeah. No, I'm sorry. But yeah, it's really very sad because wherever anything is sent there, it's usually bad because that's where I'm getting alerts. So I don't even want to open it sometimes. And also I'm using Keel, my own project for all the Kubernetes deployment automations. So what it's doing is basically it's detecting what images are you running in your GKE cluster and subscribes to those registries and listens for basically new images. You can specify policies for updates on your deployment manifests on annotations. For example, if it's a minor patch or major releases, or just force means that any new image has to be deployed, and also messages to Slack if it was success or failure. So it's quite good because then I can get a workflow where I just need to push to my GitHub, tag a new release, and then it gets deployed in a few minutes to production. Useful, saves time. The infrastructure looks pretty much like this. I have two main services that have like 1, 2 or more pods. First one is Webhook Relay API, where all the Webhook clients subscribe. It is also it's terminating TLS and also forwarding all the front-end stuff to Nginx. Nginx is running it's serving my static files. I have Nats and Redis. Nats is where I publish new webhooks because when a webhook comes to any of those pods, it has to broadcast that. So any other service that has a client subscribed can then relay that webhook to that server. I use Redis for caching and Postgres for persistence. Then I have tunneling servers that do the bidirectional forwarding to any other clients. So they are a bit more involved because they also have to pass traffic between them. Because like in the webhook forwarding case, I don't really have to get a response back to the same requester. With tunneling servers, I have to like create a bidirectional tunnels between a web server running on your own laptop and a browser. For the CI, as I mentioned before, I'm using Google Cloud Builder with Google Cloud Storage. It's like S3 alternative, really useful. Doesn't cost pretty much anything, just like for serving binaries, which is nice. And like an alternative workflow is where, I'm just pushing to GitHub and drone is building and pushing to Docker registry. And other regional deployments are stateless. So the servers that I mentioned I use Volter with, they can be always just decommissioned, purged, destroyed. Doesn't really matter. They don't have anything there. They connect back to the Webhook Relay API and through gRPC connection, so they don't even have credentials. So whenever a new client connects to one of those Volter tunneling servers, credentials get passed to the main API, authenticated, new tunnels received, and traffic can go through. So main challenges, I think, throughout the years was just deliverability, especially in unstable networks when load balancers would be cutting connections. So I kind of had to like build on top like a message queue that can ensure that webhooks do get delivered. Also, you need to have retries and so on. Then also tunnels being used for phishing, which is extremely not nice from some people, serving some bank login pages. Then weird client connections. That's also that I noticed quite recently, especially with those home automation solutions. I don't know, there are some really weird clients that, for example, just can make your Go standard web server crash. So you kind of have to extract some of the functionality from standard Go server and replace some pieces to make it like a bit more angry at some clients and disconnect them. Then, UX, worked quite a lot on it, especially like because I'm a single engineer. You always need to experiment to see like what's working and what's not. And different transport methods. Some organizations have like firewalls that block various connections, so you kind of have to jump between WebSockets, gRPC. The timeline, I started in 2016, is initial prototype, then high availability. So I moved from HyperSH to Kubernetes. HyperSH was pretty much like one of those solutions like currently there is now on AWS ECS. It's kind of orchestrator, but people are moving away from these things. Initially, I think the main reason for that was Postgres, because just having a managed Postgres on Google Cloud really makes your sleep a lot better. And then 2017 added tunnels, then lots of performance improvements, multi-region, and self-hosted. So currently, some of the clients just have a self-hosted version where they can deploy servers on-prem, especially, really helps. And now I'm working, like the next step will be executing any user code on the SaaS side. So yeah, integrating with V8, adding like WebAssembly support and Lua. So that's quite interesting. Hopefully I'll get to it. Yeah, that's it.
Cool. Are there any questions? If there are questions, then we need a microphone because I'll come up.
Throw
Give me a
it.
moment. Health and safety.
This one.
Thank you. Thank you very much for a well-presented theme. My question is this, okay? You mentioned Postgres, which is an object relational database management system, and you said Redis, and you said you were using Postgres as a persistent store. Then what's the function of Redis cache then? What's the Redis cache doing there below the API?
So I'm using Redis for two things. So one thing is there from quite ancient times just for PubSub, like messaging between the servers before I got Nast in. And another is just for caching. And also I'm keeping TLS certificates there because I'm using this Let's Encrypt library in Go that you have to implement some kind of backing store if you want to scale horizontally. So one way would be to use a shared file system like NFS, which is not nice. And I found that a lot cleaner solution is just to use like some kind of cache like Redis. Also, some of the data is stored in cache, so I don't have to hit database, especially where I collect information about webhooks and where webhooks have to go, like multiple destinations. So yeah, just mostly caching and a little bit of messaging.
Okay, thank you.
Cool. Any other questions? Up here before I have to go all the way. Oh dear. Okay, give me a moment. There's some beeping in the back here as well, so I'm not quite sure if we're gonna. Wait. Who's got a hand up yet? Somebody here had a question. Oh yeah. Okay.
Thank you. So you are using Node-RED on the client side. I want to ask about this choice. I've seen Node-RED. It seems like a graphical tool for beginners, and some people do this with IoT because they are not professional developers. As a professional developer, I would always write my own code in Node, and I would never use this tool. I'm asking you, how did it help you, and why did you make this choice?
Okay, so I'm using it on my side as well. Because I kind of treat it as a serverless platform where I can put things that don't really deserve to have their own services or daemons. So it kind of really helps just to have like a one endpoint, do something very simple like parse webhook data from Mailgun, and based on alert or like what kind of level of message it is, pass that message to Slack. Or, for example, every 5 seconds, call this API, extract a little bit of data from it, and validate it. So I kind of use it to pretty much like dumping everything that doesn't really want to be in its own service. It really helps, as I said, like a kind of serverless platform. I also use it a little bit for home automation. Through it, I control TV and light. Quite useful, and I noticed that quite a lot of people are starting to use it for a bit more serious things, not just IoT, because you can create your own nodes. It's just, for example, I created mine in TypeScript. Then you just package it and you can ship it, and anyone can install it through like a palette in Node-RED. And even in .science, we actually started using Node-RED for like a graphical tool to create pipelines for like getting the data, working with the data, and then publishing some results from that data. So you are correct that it's a tool really good for beginners, but it can be really made to work in like complex cases. or when you just don't want to have your own service.
So you say it's serverless. So how do you deploy it? It allows you to run serverless scripts in your containers.
So maybe I can show you if I had internet there. Or maybe now I can just maybe later show you. Well, it's pretty much anything that's very small. You just deploy Node-RED on your Raspberry Pi or anywhere, and then you react to events, or you can create events. So as I said, like for me, it's really helpful to, for example, even do things like I made a new release of CLI. I get a webhook from GitHub to Node-RED. Node-RED downloads the CLI, generates a hash of it, and updates brew formula for Mac installed. So you don't want to put, for example, you wouldn't want to write a Node.js server just to do this, right? It's like very small scope, and just to run a separate container for that could be an overkill. So for me, at least, it's just kind of Lambda, but you have to run it on-prem.
Thank you.
Cool.
Thank you. We've got time for one more question. Oh, hello.
Just a quick one. How do you deal with DDoS or anything like that?
Well, thanks for your question. Haven't had one yet.
So not necessarily DDoS, but I got my own public service on some IP address in some other country that no one even knows, no DNS, anything. The SSH is open, nothing else is open. I get non-stop attacks from random IPs from all around the world. And even for me, I feel like this might go bad. Even if root log is not a random username, I still feel like I should start blacklisting after a few attempts, which the actual company is doing. Like if there's like 10 failed connection attempts on TCP, it will blacklist the IP address for like 10 days or something.
Yeah, I don't know. Maybe the bad guys find out my service useful.
You mentioned banks and stuff, and I worked in a bank as well. So I feel like if I were using this in a bank, I would definitely expect something like this, which is why I asked.
I do get like scans for like admin PHP and so on, like constant thing. But
SSH is not like none of the HTTP stuff is actually available. Even the SSH gets non-stop attack on just an IP address in any country without a DNS anything.
Oh, but like in my case, since I'm running on GKE with
it's not even on the cloud.
Yeah, so it's on with GKE with Google Cloud Load Balancer. So there's not a single port available, just the ones gRPC, HTTP, and HTTPS. So I can't really get like any SSH attempts and so on. But yeah, as I understand, like I could in theory get like DDoS, but then I do have Cloudflare, so I can't.
You rely on Cloudflare.
Yeah.
Okay, that's enough. Thank you.
Cool. Well, thank you. Have a round of applause for Carolus. Cool. We'll take a moment while we'll do a little changeover. Has anybody tweeted some photos yet? I mean, you really don't want any JetBrains license. Okay, fine. It's a bit warm here, isn't it? Or is it just me because I'm standing like ridiculously close to the screen that the heat's coming out of it? Shouldn't be. Exercise, I'm not used to that. Are you ready, sir? So apparently the pub we're going afterwards is the Porterhouse. So I'm not sure who is coming to the pub. I'm definitely going to the pub because I need a drink. I mean, I'm not promoting alcoholism. You can drink non-alcoholic drinks at the pub, but it would be nice if we can have another chat afterwards when everything's sorted. Are you ready? Kind of? Yeah? All right. Give Mark an applause.
No? Yeah, cool. All right, so your kernel and you. This has been chosen kind of on purpose. So I'd like to start at what you will learn, right? What kind of things can you learn out of this? the most important is you can use memes for everything. It doesn't matter if it's a business presentation or in front of a president of a country, it's fine. You get the good oversight of how C groups work, namespaces in the kernel as well, which are very important. Maybe something else, I don't know. I'll try to throw information at you in whatever holds. So who the hell am I? My name is Mark. I'm a pesky Catalan living in London for 10 years. I organize London DevOps, so different meetup than the ones that DOMS organizes, which is like all of them. I organize also DevSecOps Days London, which happens once a year. I co-organize DevOps Exchange Barcelona, so if you're around there, make sure that you visit us. I've been working and doing DevOps in a lot of places, Rackspace, Trainline, Canonical, ASOS DevOps Group, and I've been doing DevOps for way too long. I might need a coffee by now. And I like to swear a lot, so if I swear during this presentation, I hope there's the proper beeping on YouTube. So right now I work for a nationwide building society. It's a financial institution. Nice, thank you. I'm a happy customer. Don't leave us. So just in case you wouldn't guess, we're hiring in London. So if you're interested in working Kubernetes, doing cool stuff, I'm being, I would say, being compliant with all the fiduciary duties of financial institution, then please come join us. As I said, I also organize London DevOps and DevOps Exchange Barcelona, also known as Doxalona. These are not run by Dom yet. But not yet. But if you go there and you find them not to the level of quality that you're used to, please use the hashtag not run by Dom, and we'll do our best to get to the standards that you're used to. Yeah? Nice. So do you have time to? It's important because we want to know that we're doing things right. Yeah? Cool. So your kernel and you. So sometimes you wonder what happens in your kernel. Do you feel funny? You don't really understand what's happening inside there, but you have the feeling that something's happening. Nobody explained that to you. And it's like, you ask your parents and they go, oh, no, I'm not speaking about this now. You talk about it, right? So mainly because I said, Google can replace sex education. I'm going to try to give you everything you need to know about the kernel, so there's one thing less in your life that you don't know about. So the first thing is like containers are not new. Everybody has heard of Tupperware. But besides that, cheap joke, I know. Besides that, I would say the first attempt to containers was it was more or less remarkable was in Unix. Almost when Unix started in Unix version 7, it was known as chroot. It was very hacky, very bad. You could get out of it so easy. It wasn't even any kind of container, but it was mainly a container for a file system. And then on top of that, you could run your processes that had all the same access to the kernel, CPU, et cetera, et cetera. Then in the year 2000, FreeBSD started using FreeBSD jails. That was a lot better. There was still, I would say, a lot of constraints about trying to handle CPU and all of that. So you could get containers that would use all your CPU. So it was a bit wild. And also it was FreeBSD. So seriously, who here uses FreeBSD? Yeah, one, maybe two. Yeah, well done, mate. So yeah, it didn't have a lot of traction on that. Then after that, in 2004, Solaris did what is called the Solaris containers. It was the first one that was real I/O, memory, and CPU-ish kind of containerization. They were very good, but Solaris was a commercial product. They were talking about making it open source, but then this happened. So it didn't go to open source. And then in 2006, then based on all of that, Linux had the first implementation of C groups. And then in 2016, 10 years after, C groups version 2 was deemed not risky and not experimental in the kernel and was admitted into the normal branch. So C groups it was implemented by two guys from Google. If I had my presentation notes, I would tell you exactly who. But let's say there were two guys at Google. So they did that because they were patching the version of Linux that they called Google Linux based on Ubuntu, who was based on Debian. So we kind of had something to do with that under NDA. It was based on this thing called Borg. I'm sure all of you know Borg by now. I would say, considering that Google doesn't do evil, it wasn't the greatest name ever. But nonetheless, Borg looks something like this, just for reference. I'm sure everybody finds this familiar if you've done Kubernetes at least 3 seconds in your life. So with C groups implemented, then the community started working and acting on that. And the first attempt to do a framework that used C groups well was called LXC. LXC is just literally Linux containers. I mean, great idea, greatest name ever. Has anybody here tried to use LXC? Yeah, some brave souls. Good. So using LXC more or less looks like this. I just found this as a random screenshot today. It's pretty much, it really feels as painful as that. You had to mount the file system yourself. You had to start the container. Then you had to do a console that didn't even have proper TTY, so you wouldn't even have proper escape characters. So whenever you're using that, it's like, I'm very confused. This is very complex. I'm just trying to run a single application, and if I have to do 2 of these, I'm going to cry. But thankfully, some years after, then Docker came on. Hey, yay, Docker, yay. And it made things a lot easier. So running a container was as easy as this. So this was like, yes, finally, someone that makes something complex easy. So I really felt like this. It's like, this is so awesome. It needs to happen more, yeah? So that's the history part of this. So if you think about the technical part, and this is where you will learn something. So you need to start thinking about what you need in a kernel to do a container, right? So it's a bit like a shopping list. Like I need of this, a bit of that, a little of lemon pledge here and there. So if you look at what you need in a kernel, let's say that you need an isolated file system, right? You want to write into your container. You don't want to start writing in other people's containers. You don't want to start writing in the host or anything like that, because this is your container. Everything should be there, yeah? You need isolated memory. You don't want to start reading pages of someone else or some other critical information that is on the memory of the machine. And you need some isolated CPU, right? You need to make more or less sure that you have enough CPU cycles to run your application, but at the same time, controlled in a way that it doesn't consume the whole host and you leave everybody else shouting full CPU. But then on top of that, you need isolated users as well, right? You might want to create your users inside that container that they shouldn't leak into the host. You also want your isolated network. You don't want to share your network with anybody else, because otherwise you would just be running TCP/dump, feeling like a very good, amazing hacker, because you're just reading everything from everyone. You want resource limitation, resource limitation on disk, users, network, etc. And you want some accounting as well. You want to make sure that not only that you're consuming, but what you're consuming, ensuring that everybody's accounted for. So all of these things exist at some level in the kernel, and they're called namespaces. So the problem with that name, I would say the community in general is very bad at doing names. And the problem with this name in special is that we use namespaces everywhere. So it becomes kind of meta at this point. It's like namespace of the namespace. Which namespace? The kernel namespace, the Kubernetes namespace. You're talking about the namespace in the host. What are the names that you're talking about, right? But this is just like really said, kernel namespaces. So there's 6 of them that are fully implemented right now. The first one is the mount namespace. The mount namespace, the only thing it does is that it does chroot, but a lot better. So you can mount a part of the file system or another file system inside a jail, and there's no way that you can escape that. In chroot, you could escape in many ways. In this one, it's fairly secure because it's all bounded by the kernel. You have UTS, that the only thing it does, and I know this sounds stupid, but it has a very good reason. it decouples the host name and the FQDN of the host. So you don't end up with all your containers named exactly as your host. And you want to give them names. I know cattle, not sheep, but you want to give them names nonetheless because you want to know who you're killing. But they said you shouldn't have the same name everywhere. And that, in kernel terms, is very difficult because Unix in general, the host name and the FQDN is essential to the networking system. So that's why we needed this namespace. Then, of course, an IPC namespace, because which modern kernel doesn't do IPC calls and POSIX calls and all of these. So you need to isolate them as well to ensure that they're secure. A process ID namespace, because you always know that your init or your first, or systemd now, God forgive us, systemd, your first process will be always process number 1. It should be also process number 1 inside your container, because there's a lot of things that depend on that, and there's, I would say, a lot of hard-coded software that expects process number 1 to be your init or your systemd in this case. And of course, you don't want to be running millions of containers inside the host and running out of the process ID allocation table, which stupidly is only goes to 64K. So because that was enough for everyone back then. You have your user namespace, and this is mainly, you can have 2 users named exactly the same, one inside the container, one inside the host, and they're actually different users. And you want to do that because, again, there's a lot of things that are very attached and connected to the names, to the usernames, like, for example, the Nginx user or the Apache user and things like that, in order to run web servers. And you have the cgroup namespace. So, and this is, for me, the most interesting and important one. So I won't speak a lot about it now because I'm going to go a bit more in depth about it. But then you have 2 extra namespaces, which are the time namespace and the syslog namespace. They are still in implementation. When Linus Torvalds stops swearing at all the patches that are put for this, maybe it will go all the way to stable. So there will be, as I said, to keep different time inside the machine, so you don't depend on the internal time clock of the kernel, and to be able to have different syslog channels as well, which is very useful because right now you need things, as I said, like Docker or Kubernetes or Prometheus or things like that in order to be able to channel all those syslogs and be able to segment them in some way. And these per se, if you look at them, they are very powerful. But the thing that is incredibly powerful about them is that you can connect them in any way you want. They are completely transposable. So, for example, one thing that Kubernetes does is that it doesn't use the mount namespace for networking. It uses the host networking, but then it connects all the rest of the namespaces to the host networking. And it does that on purpose in order to make networking slightly less complicated. But you can do that. You can put one on top of the other. You can connect one to the other. You can choose which ones that you want to activate. So at the end of the day, that feels like a big spiral, but it's very useful. It's very powerful, and you can do a lot of things on that. So what is cgroups? Cgroups are mainly for controlling and accounting. So it's the thing that stops your container from eating all the memory, eating all the CPU, eating all your disk throughput, all your network, and more things. They keep that. They give an idea of the container of how much it can use. It limits that, and in the worst case scenario, is capable of killing containers that are broke. So in cgroups version 1, that was implemented in 2006, you have 12 controllers. So there's 12 different kinds of control that you can control through the kernel and declare. And you have isolation per thread. So the minimum unit was a thread of processes. Right? So you cannot go further down than that. You cannot go further down than the thread. So individual processes, you cannot track them. When we implemented this in Ubuntu, I was responsible for part of that. There were 2 things that were incredibly funny and frustrating at the same time. One of them is the kernel out-of-memory killer. It didn't know anything about any of the namespaces. So the kernel out-of-memory killer, what it does is that it looks at the most active process, the most rampant memory user, and it kills it with fire, literally. So the problem with that is that you would have a container running and suddenly one of your processes would be dead and you didn't know why. Because the kernel out of memory killer would just go in, kill it with fire, and be happy and keep going on. The other problem that we had is that the initial integration of C groups was very leaky, and very leaky up to the point that you would see process IDs duplicated inside your host from different containers, and you didn't really understand why, and it was a complete mess. When you try to solve that, most of the time you would get a very nice kernel dump, and the system would stop working. So I said, if anybody suffered through that, I can only apologize. I suffered through it as well. But I would say with time, things got better. We fixed the bugs. Things were starting to work better. Linus Torvalds, with his usual amount of swearing, fixed most of the things and accepted most of the patches. And they went to the kernel, backported by all the distributions. The kernel out of memory killer started to understand what a container was, what the C group namespace was, and it would kill the whole C group namespace. So instead of killing processes inside your C group, it would just kill your whole container, which is a lot more refreshing. And then on top of that, there were a lot of the problems that we had with the leakage that were solved as well. So complete isolation was a thing in less than a year, which was very good. So if you want to look like I want to look like a real kernel hacker and start looking at those controls for C groups, you can easily go to the system FS, which is just a representation of the kernel and all the variables it has. So if you go to /c/fs/c group and do an ls, you will see all the controls for C group. You can actually touch them through that. I would not recommend it unless you want to kill your machine. Then please go ahead and do it. It's fun. But yeah, as you can see, if you can count besides the soft links, there's actually 13 here because there's systemd. Hooray, systemd getting everywhere. I really like it. So that's mainly said C groups. It just controls all these different things. You can adjust them per container. You can have full isolation. You can have full control of the CPU, memory, disk, IO, network, etc., etc. You can create different networking interfaces for each one of your containers in a complete kernel isolated way. The thing is that as with any code, it gets old. It has all these limitations, and then patching on top of patching on top of patching, it starts to look a little bit like that Volkswagen from the 60s that looked very nice when you bought it, but nowadays you only hope that it actually works. So there was a full rewrite that started in 2014. And then in 2016, it was deemed non-experimental, so it went to the main kernel. It does full isolation per process. So the thing that you can actually do is for example, the Docker and Docker thing, but you can actually do that with the kernel. You can get a process inside a container and make another container out of that process, which for some reasons is useful, like for example, security isolation and things like that. You have better use of the namespaces. So far in C groups version 2, there's 3 controls implemented that directly affect the namespaces, and you have better atomicity of CPU usage as well. So if you want to read a bit more in depth, you can have a look at that article. It is written by the maintainer of C groups in the kernel, and it explains exactly what was the driver of the rewrite and what kind of things are they doing with that. The thing is that with C groups version 2, as with anything, it just started, as I said, it's just 3 years old, which for most startups is like several rounds of funding, but for the kernel, it's very quick. 3 years is nothing. So it's still not enabled by default in most distributions. So in most distributions, we will have still C groups version 1. So almost sure that 99% of the distributions you use only use C groups version 1 so far. The good thing is that they knew about this. They knew about everything that was already running in version 1. And they made it in a way that you can actually automatically replace one of the controls of version 1 with the version 2 control. And you can have all the rest still running in version 1. So you can choose and pick which ones that you want from each version. So if you want to try it, for any reason, say you want to play with it, like I did just today in my Vagrant machine, you can actually mount it, use the mount namespace, and then it has a representation. By just doing that, the mount -t cgroup 2, it has a representation of cgroup 2. It's activated on the kernel, so then you can start touching all the different flags. So the cgroup dot whatever name, and we start playing with it. So if you want to, and if you want to set to get deeper into the kernel and all of these, please do. It's very fun. My recommendation, first, don't do it in production, of course. And second, if you do it in an isolated machine that you know you can kill, because touching the kernel is always fun, but it will make your machine explode in very imaginary ways. So just make sure that you do that in a safe way. I said safety above everything else, right? Especially, I said, in education on the kernel, be safe. So basically, once this being said, in conclusion, C groups are awesome. They are the ones that enable everything that creates containers. It builds on top of namespaces, which I said are not related to containers per se, but are the ones that enabled modern containers to work. Version 1 is still the most one used. Most problems are fixed, hooray. That's good news. You can use compostable superpowers to be able to connect namespaces in different ways and be creative. And I hate bullet lists, so I try not to use them too much. So any questions you may have. If you want to follow me on Twitter, I'm just 50 followers behind Dom. So I'm trying really hard to pass her because she's a big deal and I have to as well. So if you follow me, I'll pay you a beer afterwards, but I didn't say this.
Okay, rounds on Mark. Anybody questions? Any questions, anybody? Are you going to make me some more exercise?
Yeah, one.
Oh, yes, okay. All right.
That's good for you.
Kidding.
Great talk, Mark.
Thank you.
So, as with C Groups V1, the maturity level there allowed us to do a lot of stuff with containers and containerization. What do you see the future of version 2? Do you have a mystic ball that you can dig out some information about that?
That's a very good question. I wish I had that mystic ball. First of all, I would say the first thing is get parity of features with version 1. Version 1, I said, it was written 10 years ago, so there's a lot of things that have been patched, repatched, and overpatched. You still do have some process leakage from time to time. It's not the usual thing, but for example, Kubernetes has some killing mechanism when it detects that. So sometimes it kills your container because it leaks. So that's not 100% there. So with Secrets version 2, it was rewritten in a way that to ensure that all these things, all these problems in the past didn't happen. But of course, with any software rewrite, we'll just have newer and most awesome problems to deal with. So I said, I think it's just a question of getting parity of features, and then after that, see what we can do.
Thank you.
Cool. So people in the back, like in the back. Do you have any questions? I can run to you and hand you the microphone if you want. I'm seeing shaking heads. Yeah. Anyone up here? Yeah. Okay. Cool.
Yeah. If you're too shy to ask a question and you want to ask afterwards, I'll be the guy with the blue polo.
Thank you very much. In your very, very elegant presentation, you failed to mention LXT, the virtualization aspect of LFC.
Yes.
And you failed to mention the fact that the Lambda serverless functions run exclusively on Linux containers.
Yeah.
There must be something AWS and the other cloud providers must have seen in the strength of the kernel, especially after 2.6, for them to run Lambda functions exclusively on Linux containers.
Yeah. So I didn't mention LXD on purpose. And I didn't because it was written by a friend of mine that I really, really like, and I don't want to talk bad about my friend's software. So I did that on purpose. LXD is fine, but that's what I say.
This is being recorded, thank you. Any other questions? Anyone down there? I'm just casually strolling back. No questions? Yes, questions? What? No, yes, no?
Okay.
Oh, there you go, sorry.
Yep, again, very nice presentation. Quick question around how do you like detect memory leak? Is it only by trial and error, or do you have like more formal method to do it?
I can tell you the one that comes out of my imagination, but in reality, the way that we did that is that I would say nowadays it's difficult because mostly the errors that we have in namespaces for memory and C groups for the accountancy of memory will be race conditions. And a race condition against the kernel, it's very hard because 99% of the time the kernel wins. But it can still happen. That's when the rabbit called the kernel out of memory killer will come in and kill your kernel, your container with fire. It happens. It still happens. It's a lot more contained because I said, considering that most of the time it's race conditions that will cause that, the kernel is faster than you just because you have to go through the kernel.
Cool. Anyone else? Going once? Yes.
There you go.
In version 1, it was like say like isolation per 12 containers in version 1, and version 2 is like per process.
Yeah.
But at last you mentioned like version 1 is most used than version 2.
Correct.
So what's the functionalities between version 1 and version 2?
I said version 2 is just started. It was deemed non-experimental 3 years ago in the kernel. I said that for kernel time is yesterday. So there's a lot of implementations that are using directly kernel flags through kernfs that go straight to version 1, including Docker and Kubernetes and any other kind of container driver. So in order to adopt version 2, I said you first need parity of options. Version 2 only has 3 controllers so far. And whenever, I'm sure that, I said, Docker and Rocket and all these container engines are waiting for version 2 to have parity of features with version 1, and then they will start migrating towards that. But also you have to consider the life cycle of distros. So for example, I cannot speak for Red Hat because I haven't worked at Red Hat, but I can speak for Ubuntu. In Ubuntu, the LTS releases are 5 years old, so you have support for 5 years. What that means is that you will still have servers that are in support, so they will get all the kernel patches backported and all the security patches for 5 years since the release. I said kernel space is long, so it will take several years for version 2 to be the mainstream. So I said it just started 3 years ago. I can easily see that it will take at least 3 or 4 more years to be the main version.
Cool. Oops. Oh.
You okay?
No alcohol, promise. Any other questions?
Cool. Very important. Follow me on Twitter. I need to beat them.
I mean, I can look up the current tally. It's not a competition. But you're on 1779, and I am on 1874. So get following, people. All right. Any other questions? No? Cool. Give a very big round of applause for Mark.
Thank you.
Awesome. So we will have a short 15-minute break. So get yourself watered or get some, go to the toilet or whatever. I'll be here back 5 minutes before 8:25 for Kevin's talk.
Check 1, 2. Yeah, it's on.
Hi everybody. Just a quick one. We're not starting just yet, but if you need to leave level.
Ladies and gentlemen, just a small announcement.
If you need to leave the building, go to level 3 or press the star button on the lift. Level 1 will take you to the basement, which is what you don't want.
But if anybody can take their places for the last talk, that would be great. Everything working? Yeah. That's very tricky, by the way.
Yeah, hopefully it works. I'm not used to using Google Slides.
Sorry?
When we had an edict passed down in Google Slides, which is what that is.
So, funny story. Well, not really funny. I mean, it's just a thing. But was anybody of this group here for the last year's Christmas Docker in November?
Did y'all do?
Because it was very funny. Because we went to the pub afterwards, and there was karaoke. And those of you who know me very well know that I love a bit of karaoke. So. Thank you, Josh. Right. Okay, if everybody's ready, I think we are ready for the last talk. Please give a warm round of applause for Kevin from Instana.
Hello, everyone. So I want to give Dominique here a very warm thank you for inviting me to speak tonight. I appreciate it. This is my first time in London. I've been here for about a week, and I've enjoyed the city so far. I'll be sure to come back at some point, I'm sure. So this is my talk. This is the title, Microservice Observability. And really, it's just the idea of coming to a better understanding of how our environments work and how microservices operate in the wild. And that's what we're going to cover tonight. So if my remote would work. This is why I don't like Google Slides. Here we go. All right, so aside from the giant picture of my face, I do developer relations at Instana. We are an APM, application performance monitoring company. I work in the education awareness area. That's the whole developer advocacy part of the job. And I also work on the product focus for SRE type topics, things like artificial intelligence, as well as alerting and management, things around SLIs and SLOs. And I kind of help our product team understand what the needs are of DevOps and SRE type personas in our company. I also contribute to open source, whether it be creating demo applications or workshops, as well as applying any kind of changes upstream. And I've done some work with Terraform as well in the past. So when I'm not doing the developer relations, I work on a small startup called Single Music, and I'm the principal SRE there because I am the only one. So my role there is as a co-owner and a consultant. I built the delivery system on Docker Swarm a few years ago, and it kind of just works, which is the beauty of Docker Swarm. And since then, I really just make sure things don't catch on fire, or if they do, that I can put that fire out. So that's where the maintaining production excellence comes from. I've been doing software in some shape or form for around 20 years. I learned about Docker in 2014 after watching a video of Solomon at PyCon, and I was like, okay, that looks awesome. And I put it into production the next year. And since then, I've been named a Docker captain, a GitLab hero. I run the Nashville Docker meetup, as well as the Nashville DevOps days as well. So it's just a little bit about me. If you want to follow me on Twitter, there's no way I'm catching up with you, Dom. So no threat. So what we're going to talk about this evening is what observability means, what that term has come to encompass today and over the past, I don't know, 50 years. what is distributed tracing, how that plays a role into it. Also, really what the monitoring landscape looks like today. And finally, we're going to talk about how we use these tools at Single Music. So observability, theory, and reasoning. Observability is actually rooted in control theory, which was a paper that was published in around 1961. And this dude told us that a system is observable if the behavior of our system can be determined by just looking at its inputs and outputs. The lesson that we should probably take away from that, though, is it's well documented. And it's a valid approach for figuring out how our systems work. And even back then, they had really complex math theories to determine how observable these really complex systems they were building. I mean, this is the kind of stuff they use to go to the moon. So if they can do it, we can do it. So what observability should enable us to do in modern architectures, it should enable us to find patterns. It should allow us to assign sub-significance to those patterns, help us reason about them, and finally, give us some guidance on how to act on it. Like, what do we need to do with this data that we're collecting? Colloquially, I like to say that observability is looking, monitoring is seeing, and then controllability is acting. And the reason we need this is because as we adopt those microservice environments, as we adopt these new patterns of architecture, serverless as well, the rate of change and the complexity ramps up. And really our only choices here are to either adapt or collapse. There's no real right in the middle ground. And they talk about that quite a bit in the DORA State of DevOps report and with the J curve of transformation. So how many here runs the staging environment? A few hands, yeah? How many of you actually trust it? Right, not as many hands, right? And this is why, because our users run rampant in our production environments, and it's really hard to emulate that in staging. It's not impossible, but a lot of us have many other things we could be working on than trying to get this in staging. So distributed tracing is this observability. Now, it's maybe, I don't know. I would argue no, it's not. It's definitely, observability is not sex education, by the way. We do have a mirror on the ceiling, though, for whatever it's worth. So what distributed tracing is, what's the abstract, right? And in 2010, Google wrote a technical report about Dapper, which was their distributed tracing solution. And there's a lot of text up there, but what it's basically saying is that as they built out these large, complex environments that was built by different teams using different programming languages and could span many thousands of machines across many physical locations, that they needed tools to help them better understand and aid in the performance issues that were coming up. So if we start talking about, well, how does distributed tracing work? It's pretty simple. And I'll break this down a little bit further in the next couple slides, but essentially every request that our system generates, and that could be a transaction from REST API, gRPC, RabbitMQ, Kafka, you name it. Anything that makes a transaction across the network, we are attaching headers or information to it that helps us correlate it. So what we can see up here at the top is we have a front-end request. That's the initial request. And we have no parent ID on it because it's parentless. It is an orphan. And then we have a span ID, which is uniquely generated for each individual transaction. Down here at the bottom, we have a subsequent call, and that back-end call is maybe making a request to a database to get some information, but we give that its own span ID and then assign it to a parent, which is the one that happened before it. And then so on and so forth. It just goes, it's all turtles, right? So that gets visualized into a Gantt chart. And another way to look at this is it's just simply we're tying a bunch of transactions together. And on the other side of it, we're collecting that data from those transactions and those headers, and we're stitching everything together. We're making correlations. And what that'll look like is something like this, where we get an idea of the individual endpoint, what was called, what the timing of it was, and also we get some other rich information like, was there an error? Or what was the stack trace if there was an error? So what do we get from all this? We get a ton of telemetry. which is great for aggregation. It's great for machine learning. It's also pretty good for performance analysis and debugging, but it also creates a giant data lake where we drown if we don't know how to manage all that data. And that's where we're kind of at in the current ecosystem. So let's talk about that a little bit. We have legacy tooling. Many of you probably are used to being exposed to that. Things like Nagios, StatsD, SNMP, Zabbix, those type of tools. Those are really just completely unsuited to handle the rate of change these environments are going through today. And then we have modern open source, which is actually getting very well equipped to handle that type of change. We have Prometheus operator now. We have a Jaeger operator as well. And these things will almost just auto-wire themselves to start collecting that data for you. But it doesn't address the data lake problem. We still have to analyze that data. We have to create these buckets. We have to roll up. We have to create these logical units of information that we can act upon. And then, of course, I personally don't want to hire a bunch of data scientists to figure this out. I want them working on my business problem, which is where we start talking about vendor tools. And I don't want to pitch, but the idea here is that if you want to get that value out of the data, you're either going to build it yourself or you're going to pay somebody else to build it. There's really no, right now in the current ecosystem, there's no getting around that. So how do we get to this state, right? Because when we talk about monitoring currently, what we do is we shove a bunch of data into a database, into a table, and then we build queries and we pull that data out and we visualize it somehow. But what we really should be looking at and trying to wrap our head around is combining all this data. We still need to query this data. We still need to collect it. And we still need to put it somewhere. But then we need to bring it all back together. And this is a Venn diagram from Peter Bourgeon, who wrote this in 2017. And he said that if you bring all of them together, what you ultimately get is what's called request scoped aggregatable events. And I'll explain what that means. But in summary, and if we're taking it down to layman's term, it means we're not treating services like Schrodinger's cat. We're not just throwing it in the microwave, right? Is it alive or dead? We have a lot more context around the interactions and the transactions of our system. We can generate interactive dashboards that allow us to really dive into the data. And I'll show you what that looks like in a few slides here. So how do we get that though? Like, how do we build that? Well, we create these individual buckets of data, right? And we can scope them based on things that we logically connect them to, things like groups of services or groups of applications. And then once we have that, we can roll up golden metrics. We can do things like, well, what was the mean latency across all those services or all those endpoints in that service? And then we can also do things like, well, what's the throughput? What's the error rate? And that's what we call golden metrics. And that's from the SRE handbook from Google. And that will help us really ascertain the health of a service pretty easily. It's not all that we take into consideration, but it's a pretty good indication. If our service is rocking the throughput, has good latency, like low latency and really low error rate, we can kind of assume it's probably healthy, right? So what do we get if we start taking this approach to our monitoring? Well, we get the ability to alert humans when the machine detects there's a deviation or an anomaly. We can also build those summary dashboards, those interactive dashboards that let us immediately bubble up those indicators that there's a problem, and we can go dive into it. And again, we can use machine learning. So Single Music, how and why we use observability tools. So Single Music, it's a company that I started with a couple friends a few years ago. We haven't really grown the engineering team, even though we've grown the company significantly. We've had about 400% growth. At peak periods, we roughly run about 20,000 transactions per hour. That's not sales. Like there's a little bit of an ambiguity in that term, but it's generally how many interactions our system has internally to process our workload. We have over 20 integrations, about 150 lines of code up to this point, and we're able to operate with a pretty low test coverage percent. And I bolded that because most people talk about, I've got 90% test coverage. Screw that, I got 15. That's awesome. So We launched in 2018 with 15 microservices on Docker Swarm. We're up to 40 now, I think, and we haven't had to add new personnel. And that's because we built a one-touch deployment system and a provisioning system so that the developer on the team could just declare a new service and off he went, because I'm super lazy. Like, I don't want to do anything. So the more I can let him do, the happier I am. And we have roughly around 10 to 25 deploys a week, sometimes more, sometimes less. Who knows? And we have some pretty big bands, right? Y'all might have heard of some of those. This couple weeks ago, Tool put out a new album. We had Lana Del Rey, and we also had somebody else. But we were like responsible for doing sales for 3 of the top 5 Billboard artists. And we're able to do that because we have some pretty good monitoring in place. So what does single music do though? Like what, yeah, I get it. You guys are growing and you're awesome, but what do you do? Well, we do digital music sales and physical music sales reporting. We do fulfillment and distribution as well. We do sales tracking, landing pages, analytics and reporting. We have integrations with a bunch of stuff so that people can kind of socialize their music. So how do we visualize? How do we monitor this? Right. What I'm going to show you next is a 3D diagram, and each individual stack that you'll see here is a host, and within each one of those hosts, you'll see little pancakes or stacks of containers, and I'll explain from there. So here's the representation of our infrastructure. AWS, we have multiple availability zones. I just switched to a production view to look at our production containers. I'm clicking on a host here, and I can see all the details about that host, as well as what's running on it. So Spring Boot applications, some Elasticsearch, some random stuff. Now I'm opening a dashboard that's showing me the metrics for that service. So I can look at things like, what's the thread count? What's my garbage collector doing? You know, what's happening with my service? So it's pretty simple, easy way to see the general health of my system, because if Instana detects any problems with any of those containers, things like high CPU load or memory getting close to that container limit, it's going to turn yellow. And if it is really unhealthy, like it's throwing a ton of errors, it's going to turn red. So this is a diagram of all the transactions that are actually happening in our system in real time. And these are, as I said, these are broken up into those buckets, right? So individual services, and each one of their transactions are represented, and I can see those golden metrics. I can see the call rate, the error rate, as well as the latency. And now this is all generated dynamically on the fly based on all the data that's getting pushed into Instana. It's a lot of data. So how do we, that's great and all, but how do I use that? How do I get information out of that? And we do that because we have these interactive dashboards which roll up all that data. So what we can see here is we have a summary dashboard of all of the services that are running in my production namespace. Again, this is Docker Swarm terminology, but you could easily apply it to Kubernetes or anything else for that matter. Up here we have the throughput, which is essentially a representation of all the calls that are coming into my service over a period of time. This is over 12 hours. So we can see a histogram of really the how busy my services are. And then we can also see a histogram of the errors. Plus we can see the latency percentiles and the processing time. So this gives us a couple different things. And I want to unpack that because we have up here at the top, 50, 90th, 95th, and 99th. And what that is like, what that tells us is with the 99th percentile, that means that 1% of my requests have a latency in that purple line. So what that's telling me is that some of my requests are a lot slower than the other ones. And this might help me understand that there could be an indication of a problem that is kind of just waiting to unveil itself or reveal itself. And this helps really kind of understand where in my system there might be a problem, because if all you're doing is you're looking at the average latency, this is going to get swallowed, right? The 99th percentile is going to get wiped out because 99% of the other requests are doing just fine. On the bottom, we have processing time broken apart by database, as well as messaging system and the HTTP, so REST API. The next section is where we can do some troubleshooting pretty quickly. And over here on the top, we have these little buttons that we can click on that will actually change what is represented here. So if we click on calls, it would change to show us the busiest services essentially. Or if we clicked on errors, it would show us the services that have the most errors. And if what we're interested in is the most latent, I can see that the sound scan service is showing me that for the average latency, it's serving around 930 milliseconds. I may want to go dig into that. What would that look like, right? Well, it would look very similar to this, but I would have individual traces for that service rather than multiple services over here on the right. So the same thing applies here, where each one of these endpoints tells me how busy or how erroneous a particular service is. So this is that Gantt chart I showed you earlier, but like legit. Like this is somebody creating a new product line in their store, and we're gonna kind of unpack what's happening here because it's quite a bit of stuff. So up at the top, we can see that over 2,000 interactions were made to complete this transaction. And within that 2,000 transactions, there were a few errors, right? We detected that there was some error logs generated in our code as well as warnings, and that actually one of these transactions, one of the 2,041 transactions came back with an error code. And that error code could be something like a 500, or it could be a database transaction that came back as an error. And then we also have the figures around latency and the call duration. And let me explain what the difference between those are. Latency is a measure of how long it takes for a transaction to be fulfilled to the client. So on here on the left-hand side, we can see that this transaction came in, a post came in to this endpoint, and it wrapped up around 35 seconds. But then underneath that, a bunch of other stuff happened. And this was because our system is built on RabbitMQ, and we do a lot of work asynchronously behind the scenes because this work down here in the lower corner isn't necessary to fulfill that request to the customer. So this tells us that, yeah, the customer's request fulfilled in around 30 seconds, which is probably kind of slow, like maybe we can fix that. But most of the work is taking over 2.5 minutes to finish. But that's important to know because there's a lot of stuff that happens in here and we want to know if something breaks. And in this case, something did go wrong, right? We can see here on the corner here that there's a red exclamation mark and a marker. And if we click on that, we get taken to the actual details of that transaction. And we can see that a request was made to some kind of dispatcher or handler. It was put onto a message queue and then consumed by a service. And on the right here, we've collected the details from the database where we can see that, well, it looks like there is a duplicate entry. And in this case, it was just an item potency error, right? Because we didn't check that this hadn't already happened by some other worker. And that was the case here, is that work had already been done by something else. So it wasn't catastrophic, but it was still something we want to know about and that, well, we can easily fix. Now, where I think the future of monitoring is going is that while I just told you what the problem was, we had to go investigate that, right? We had to go look that up. What I'd like to see in the monitoring in the future is that this system would detect that this query had already happened in this transaction and could tell you, you have an item potency problem. Here's where it already happened. So I didn't have to do that investigative work. We're not there yet. We're working on it. But again, this is where my feedback to the product team is really instrumental in kind of building out that kind of features, those kind of features. So in this next slide, again, we have a summary of all the services within the production application that we're running up here. And this gives us an indication of what the technologies are, what the domain of these individual services are. So things like what frameworks it's using. Is it a database? Is it using the messaging system? Is it running batch jobs or is it running serial type jobs? And then we get the complexity of them. And the number of endpoints in a service is a good indicator of how complex something is, because the more endpoints you have, the more responsibility it has, right? Because if we associate endpoints with work, then the more endpoints there are, the more work the service is going to do. And this could help us also kind of determine, when do we refactor? When do we start splitting up these services into smaller services or functions? And then, of course, we have the golden metrics, as I mentioned before: throughput, the error rate, as well as the latency of it. And then finally, the indicator of health, which is a factor of many things, but we're looking at things like, is the throughput healthy? Is there a big drop that just happened? If there is, then that might not be healthy. As well as like the error rate. Was there a sudden spike in errors? And this is where the machine learning comes in, because if we analyze all of this data over time, we can do something called change point detection, which will help us do factors or factor in the probability of an issue, right? So how do we use tracing in a more holistic way? How do we help it understand our architecture? Again, this is an asynchronous transaction. At the top, the request is fulfilled, and then we have individual tasks being done underneath that. But we can also look at the individual ones and visualize things like patterns in our algorithms. So we can easily visualize things like exponential backoff. And we're also able to solve problems. You can see here on the right-hand side where we have a slow rise in latency. And this was brought about because we had we built the transaction system in a way to where every single transaction that was generated in our system would load all the other transactions. And that caused a problem, right? O(n) log n, rise in latency. And all of a sudden we were a real risk of actually breaking our system. However, because we had this in place and we could see that, we deployed the fix and the problem was resolved. This was the other thing that we noticed too, is we had some blocking actions in the Gantt chart we were looking at. And this was from interacting with auth0, and we would go and request a token every time we would kick off a new thread or a new worker. And we were like, well, what if we just cache that, right? Well, we did, and it fixed the problem, but what we didn't account for is 6 months later, auth0 changed their policy around after about 30 seconds, that token would expire. So we had to go get a new one. And we caught that because that Gantt chart showed that around 30 seconds, we had a ton of errors coming in. And we were alerted to it, and we were told what the error was from the solution. We were told, okay, well, here's the error log and the parameters of it. And then we were able to fix it. So you can see here that past 30 seconds, the transaction does just fine. So this next slide I'm going to show you is us looking at a list of those errors or some errors and being able to jump to the trace. So we have error messages. We're able to jump to the traces, and we're able to quickly investigate the whole context of that issue. And the point I'm getting at here is this really plays into that Venn diagram that I pointed out earlier, where we have logs, we're able to jump to the trace, and then from the trace, we're able to jump to the backend infrastructure and look at the metrics at that time. So say we had a garbage collector going crazy that caused the system to slow down and time out, and that created a log message. Well, we can investigate that very quickly if we connect all those pieces together. So we're able to also build custom dashboards, and we're using Grafana because we do have a plugin for that. And these dashboards took me around 5 minutes to build. It wasn't too terribly complex. And it's all because we were able to pull that data just directly out of Instana. So just to summarize everything we covered, which is quite a bit, the first thing I want to point out is microservices really helped us meet the needs of our customers, because we're able to scale and build very effectively and very rapidly. We were able to really embody the DevOps methodology and practice and culture. And secondly, observability tooling has helped us maintain that production excellence, making sure that if there is a problem, we know about it before our customers come and yell at us at Twitter. And then we're also able to, so that means we're able to focus on the problem at hand, which is making sure that we can deliver the music to the customers and make our the bands and the artists happy. So that's great and all, but I don't want to spend money on this. So what do you recommend, right? Well, first thing I'm going to recommend is you use tools that allow you to leverage distributed tracing and things like Prometheus and logging. Because later, that's really going to make your life easier if you have those practices in place. Because if you're using those types of tools and those types of practices, then adopting a managed solution doesn't become such a large ask later down the line. At a minimum, I would recommend you do a POC with open source tooling, things like Jaeger, Elastic, as well as Prometheus, and I don't know, there's a ton of them out there, right? But the point here is that you understand the problems you're trying to solve, as well as what kind of value vendors are going to bring you. And we're not the only monitoring vendor, right? There's plenty of them out there. Ultimately, though, share your success. Talk to people about what you're doing and how you're doing it and the problems you're solving. Because ultimately, most people aren't even aware that this type of functionality exists, right? That you're able to dive that deep into your system. So with that, I think I have about 2 minutes or 5 minutes for questions. So I'd love to answer any questions you'll have. It's a lot of stuff we just went through.
I mean, a little applause is fine.
Yeah.
Any questions? Last time for a little exercise.
Yeah.
I'll go on then. Oh, doing the double steps.
Hi. So in order to get this level of observability, do you need to build some of external software into your code, or can you do that with just the metrics and logs that your software already provides?
Okay, so there's two parts of that question, and I'll answer one at a time. The first one is, do we need to build additional code, or do we need to create additional instrumentation in our code, right? And the answer is it depends. And it depends on a couple of different factors. One is the language and the framework, and also your architecture. So Single Music is all Java based, and we have some Go services as well, but that's mostly to manage the delivery pipeline stuff. But with Java, because of the way that language was architected and built, Instana can actually connect to the process at the host level, right? Mm-hmm. Once it connects to the process, it can inject through a byte loader the instrumentation package. And once that library is loaded, it then wraps around all those communication methods and does the instrumentation for you. So what that ultimately means is, like, within literally 5 minutes, once I had the agent on the host, it was able to automatically instrument all my services and give me all that information that we just saw. Other languages aren't as forgiving. So if you look at something like Go, like you're gonna have to import the library at a minimum, and then depending on what frameworks you're using, like if you're using Mux, we're gonna auto wrap that. But if you're using some home baked thing, like where you just kind of made it yourself, then you'll have to use the SDK to actually instrument. Again, it's a complicated answer because there's so many variables there. I don't remember the other question. Sorry.
Can you get some level of observability with just the logs and metrics that you?
You can get some basic information, but one of the things that Instana does that I think is pretty cool is with that information we gathered through tracing, through all those individual transactions and all those timings and the response codes, we can assign health to that data, right? So if you don't have distributed tracing, you can't do that, right? So that's the challenge. Now, if your system isn't as complex as what we just looked at here, who cares, right? But if you're looking at an environment where you have many microservices, you probably want distributed tracing. It's kind of like you have to have it almost. You're welcome.
Cool. Now I'm up here. Any other questions?
Got one right here, Tom.
Oh, I'm gonna
Oh, no.
sneak
Oh,
up on the
yeah.
back.
Okay.
It's probably easier.
Right behind you.
Surprise!
Surprise.
All right, thank you. So you already mentioned how you guys integrate with Java. What is the exact integration and support for Python?
Very similar, I think. If you look at, it's all in our documentation, and I don't necessarily want to jump there, but I believe with Python, we have the same level of functionality with Python 3. Probably. I'm not 100% sure. At a minimum, I mean, like in most cases, you can get away with just introducing the library in the code yourself. And then once the library is there, it does all the other work. Unless you're doing something like you're communicating over WebSockets, which God help you. But if you're doing something like that, then you obviously have to collect that data and pass it through the WebSocket as well. Or if you're doing direct TCP connections. But as long as you're using technology in which allows you to use headers or some type of metadata, typically we just automatically trace that stuff. Yeah, you're welcome.
Cool. Anyone else? Oh.
I just wanted to ask something. You just mentioned Python.
Yeah.
I mean, the live stream wants to probably hear it too.
Yeah.
Thank you very much. Python integrates very well with the JVM of any web application, actually. It's part of the framework. It's an interpreted language, a passive language that sits on top of the JVM. You can remember that the JVM itself, the Java Virtual Machine itself, is not really Java agnostic per se. It accepts other languages, other passive languages that sit on top of it. So in my experience of moving a client onto the Azure cloud itself, Python sits extremely very comfortably with the JVM frameworks offered by Spring Boot. So that wouldn't be a problem at all.
Was that a question for?
My question was about, you mentioned about Prometheus.
Yes.
Prometheus is a monitoring tool, from my experience, is just a reactive tool. It doesn't proactively monitor the instances of failure. It doesn't warn you ahead of time. It just tells you when something has failed.
Yeah, absolutely.
Okay. Is there, well, does the Instana, is the preferred solution you were offering, does it proactively monitor the instances to warn you ahead of time?
I couldn't quite understand you. I'm sorry.
The monitoring tools that are available at this moment in time from Helm, looking at your examples we were using was on Docker Swarm.
Yes.
Okay, we're using the AKS service.
Yes.
And we're using Kubernetes with Prometheus.
Right.
Prometheus does not have the capacity to proactively monitor failure. It reacts.
Yeah, absolutely.
Which is not helpful, because you want a monitoring device to be dynamically, proactively looking at instances potentially for failure.
Right.
So you can take reactive action. You don't have to wait for it to fail. Then everybody starts complaining. What other solutions, what other technologies do you think are out there that can proactively go around looking for the instances in the microservices environment to detect failure before they happen?
Well, I think that's where distributed tracing comes in, because you're essentially collecting data on everything. And it's a tricky proposition, because when you collect that much data, there's always some level of overhead. But without that information, then how can you be proactive about your environment and your situation, right? So if you're collecting data about all those individual transactions, and all of a sudden you have the data's there, you just have to know how to look at it or how to find it. That's where managed service providers such as Instana, and again, there's other ones out there too. You got Dynatrace, Datadog. Yeah, I mean, like they all have some measure of intelligence when it starts when it has all that data. It can start looking at it and making some general assertion about the well-being of your system, right? So I think there's room for growth with the open source tooling out there to help bring that level of visibility, but I think we're still several years out before that is a realization. Yeah.
Cool. All right, on that note, I think it's time for the pub.
Yeah,
give a great round of applause to Kevin coming all the way from the States, and to Mark and to Carlos for doing amazing talks as well. So that concludes the September edition. Whoop. So where's Jonathan? John? Is he still there? Okay, so John said to go to the porterhouse. If everybody could follow him to the pub, I'm sure there'll be some. I think they're turning off lights and stuff. I think we need to go. Okay, so lift, 3rd floor, porterhouse, have a drink. See you next time. Bye.